Welcome to session on quadratic equations. So, focus on the screen. The general form of a quadratic equation would be in the form of ax square plus bx plus c, where a, b, c, the coefficients a, b, c are real numbers and a should not be equal to 0. Let us try to understand. See, the equations are formed to solve real life examples. So, to solve something real, the domain of the solution should be real. So, we should be dealing with real coefficients. That's the reason why the coefficients a, b, c are real numbers. And a should not be equal to 0. Why a should not be equal to 0? If you see, the power of the variable is 2. Okay, only then the equation becomes quadratic. So a quadratic equation will always have power of the variable as 2. So what happens if a is equal to 0? If a is equal to 0, the term ax square would become 0. Then your equation would be reduced to bx plus c, and it is no more a quadratic equation. That is the reason why we say a quadratic equation ax square plus bx plus 0, where a, b, c are real numbers. The coefficients a, b, c are real numbers and a must not equal to 0. If a equal to 0, it's no more a quadratic equation. Clear? Okay. So before we move further, let us discuss something about roots. So we know that square root of 1 is 1, square root of 4 is 2. But this 2 can be plus or minus. So if you take minus 2 into minus 2 is 4. So that also satisfies. Plus 2 into plus 2 is 4. Square root of 5 is 2.236. So it is above 0. Okay. So far so good. When the value under the square root symbol is positive, we are getting a root. Even for 0, square root of 0 is 0. So as long as your value is 0 or positive, these roots, there is no problem in following the roots. But suppose, now consider this, what would be the square root of minus 1? Let us take a simple negative number. What would be the square root of minus 1? It is very complicated. Although there are solutions for it, that doesn't fall under real numbers. So that is the reason whenever your value under square root is less than 0, if it is greater than or equal to 0, it is fine. We can deal with it normally. But if the value is less than 0, then the roots of such a square root are imaginary. They don't fall under real numbers range. Okay. So therefore, underneath square root, if it is 0 or more, if it is greater than or equal to 0, we can easily find out the roots. But if it is less than 0, then the roots are difficult to find. They are imaginary. Keep this in mind. This concept will help you in understanding why a negative value square root is complex. Okay, now the generic form of quadratic equation ax square plus bx plus c can be solved in two ways. You can solve using the coefficients a, b, c. By rearranging this equation, you can arrive at the two roots of value x. That is one way of solving a quadratic equation. Another way is, if we can factorize this equation, that is, if you can reduce this equation to this form where it is expressed as factors, coefficient a into x minus alpha into x minus beta. These two are linear factors. If you can express ax square plus bx plus c as linear factors, then this is one form of solving. This is one method of solving for the roots. Okay, let us discuss factorization later. So now, using the coefficients, how we can arrive at solution. So this is also called derivation or proof of roots of a quadratic equation. So there could be a theory question: derive the roots of a generic form of quadratic equation, or what is the proof that two roots of a quadratic equation are such. There could be a question on this. So let us see how we will arrive at the roots using derivation. So ax square plus bx, if I take the c, the other side, it becomes minus c. Now on the left hand side I have ax square and bx. So I want to get rid of this a. So I will divide throughout by a. So I will get this equation: x square plus b by ax is equal to minus c by a. Now look at the left hand LHS left hand side. I want to express this in this form. So if you see here in this equation, p square plus q square plus 2pq. So p square is nothing but x square here. See, this is nothing but x square, and 2pq is nothing but bx by a. So I want to introduce q square on left hand side so that I can write the left hand side as in this form: p plus q whole square. Clear? For that reason, what I will do is I will add b square by 2a whole square on both sides. I will add this quantity on both sides. So I am not changing the equation. So why I am adding b by 2a whole square on both sides? Because I want to put the left hand side in this form so that in the next step I can take it as p plus q whole square form. So I am adding b by 2a whole square on both sides. So this is I am adding on left hand side, and this I am adding on right hand side. Clear? Now left hand side, you see, it is in the form of p square x square q square b by 2a square and 2pq. If you add 2pq, you will get b by ax. So left hand side is in the form of p square plus q square plus 2pq. So I can write it as p plus q whole square. So what is p here? X. What is q here? b by 2a. This is q square, right? So b by 2a is q. So x plus b by 2a would be p plus q. So I have reduced this to this, simplified it, whole square. Okay. Now the right hand side, you see. So b by 2a whole square. I am taking square. So b would be b square, and 2 square would be 4, and a would be a square. So b square by 4a square. So on right hand side, if I take 4a square as LCM, so this would be minus 4ac plus b square. Clear? So left hand side would be the same. So here I can rewrite this equation as b square minus 4ac by 4a square. Okay. Now if we take square root on both sides of the equation, so square root of left hand side is equal to square root of right hand side. Okay. So when you take square root on left hand side, this square root and this square gets cancelled. So you will end up with x plus b on left hand side. On the right hand side, as we have earlier seen, the square root of 4 could be plus or minus 2. The answer could be plus or minus 2. Okay, likewise, square root of b square minus 4ac by 4a could be plus or minus b square minus 4ac by 2a. So here I am taking off the root of the denominator, where 4 root is 2 and a square would be a. Clear? So if I take this term to the right side, it is plus b by 2a, it will become minus b by 2a plus or minus under root b square minus 4ac by 2a. So if I rearrange it on same denominator, I am getting this equation. So here this is the solution for x of this quadratic equation. This quadratic equation where we need to find the value of x. So this is the value of x. So if you take plus, this would be one root, and if you take minus, this would be another root. So you arrived at two roots. So this is the proof of roots of quadratic equation, or you can say derivation of roots of quadratic equation. So this derivation you must understand. Clear? Now before we go to another method of finding the roots. So here we found the roots using arranging the equation and solving for x. So this is one method of for finding solution, that is the roots of given equation. Another method is factorization. So before we go for look at what is factorization, we need to understand one small rule. It is called zero product rule. So what is zero product rule? If d and e are some real numbers, and if d into e is 0, d and e are real numbers, the product of d and e is 0 if it is given as 0. This means either d should be 0 or e should be 0. This is called zero product rule. So we must understand this rule that we will use in factorization method of solving the quadratic equation. Okay. So in factorization method, we simplify the given generic form of quadratic equation, that is ax square plus bx plus c is equal to 0. This is generic form of quadratic equation. We should simplify this equation to find out two linear factors. So the same equation, left hand side, we should be able to express it as a product of two linear factors in this form: x minus alpha into x minus beta. Sometimes you have a coefficient a, that could be a, or a could be 1 or it could be any value. So if you are able to reduce the left hand side in this as a product of two linear factors, then your solution would be using the zero product rule. Either x minus alpha is equal to 0 or x minus beta is equal to 0, because the product of both is equal to 0. So either of it should be equal to 0. So if you equate x minus alpha is equal to 0, you get one root as alpha. If you take x minus beta is equal to 0, you get another root as beta. So these are the two roots. Clear? So a quadratic equation is an equation where the power of variable is 2. So generic form is ax square plus bx plus c is equal to 0. The roots of quadratic equation can be found in two methods. One method is solving for the roots in as an expression of coefficients, and the second method is expressing the quadratic equation as product of linear factors and finding the two roots. So the second method is called factorization. The first method is actually called discrimination method, but we will see discriminant method. We will see what is discriminant and all. Okay, clear? Okay. So now, even before solving a quadratic equation for its roots, we can comment or we can like find out the nature of those roots. Okay, so we had seen earlier square root of a negative number is slightly complex, whereas square root of positive numbers or 0 is okay, is very easy. But whenever you have a negative quantity under square root, then it will lead to complications or the roots could be imaginary. This you need to understand. Here, as we have seen in the earlier proof, the quantity b square minus ac, see this quantity, whatever we found, b square minus ac, this quantity is called as discriminant d. Okay, without solving for roots, looking when we arrange the given quadratic equation in this form, ax square plus bx plus c is equal to 0, from that we can figure out what is a, what is b and what is c. So once you know what are the coefficients a, b and c, the quantity b square minus 4ac, this is called a discriminant and is denoted by capital letter D. Why are we calling it as discriminant? Because we are discriminating the roots using this value. So if the discriminant is greater than 0, the roots would be of some nature. If the discriminant is less than 0, roots would be of some nature. If the discriminant is equal to 0, roots would be of some nature. So we are using this quantity D to discriminate among the roots. That's why we are calling it as a discriminant. Okay. So we have seen earlier, if we can find out what is the discriminant, so one root is given as minus b. See the same thing, instead of b square minus 4ac, you are expressing it as d here. So minus b plus under root of d, the first equation, this would be first root, and minus b minus under root of d, this would be second root. And it's a convention to denote the roots with the Greek alphabets alpha and beta. Okay, so even before we actually denote or find out the actual roots alpha and beta, we can in fact comment on the nature of the roots looking at the value of d. Okay, so first is, if d is equal to 0, if the discriminant is equal to 0, straight away we can say the two roots are equal and the two roots are real. Okay, so the first way of determining is, if the value of discriminant is 0, you can say that the two roots are equal and the two roots are real. The moment d is less than or greater than 0, you can say the two roots are unequal. Okay, and depending on whether the d is greater than or 0 or less than or 0, we can comment further. So the first way of looking at equal or unequal roots is, if d is equal to 0, the roots are equal. If d is not equal to 0, that is either d is greater than 0 or less than 0, the roots are unequal. So let us see what happens if it is less than 0. If d is less than 0, first we know that roots are unequal. Second, as we saw in the expression of finding the roots, we are taking square root of d. So when d is less than 0, you know that when is d less than 0? When it is negative quantity. So under root of d would be some imaginary. So this will lead to some imaginary numbers. So you should be able to say this. Whenever the discriminant is less than 0, the roots are unequal and they are imaginary. So they are not real. Clear? Okay. Now, when the discriminant is greater than 0, that is positive discriminant. When discriminant is greater than 0, Still the roots are unequal, first point. Then if D is a perfect square, do you know what is a perfect square? Like 4 is a perfect square, 9 is a perfect square, 25 is a perfect square. Okay, so these are all perfect squares. If D is a perfect square, that is, you can find the square root close to an integer, then the roots are, okay, so let us see if when, first of all, when D is not a perfect square, then you will be able to remember when. So assume D is not a perfect square. Okay, so if the discriminant is greater than 0, you know that the roots are unequal. Then if D is not a perfect square, if you take out the square root of D, then it would be some 2.3376 or some value like that. It is not exactly an integer, so it has some decimal values. Then it is not a perfect square. So if your D is not a perfect square, then the roots are irrational. Clear? When the D is positive, the roots are unequal. When the D is not a perfect square, the roots are irrational. So what if the D is a perfect square? So when D is a perfect square, that is D is above 0, positive quantity, then the roots are anyway unequal. If coefficients A, B and C are rational, then the roots are rational. If the coefficient B is irrational, then the roots are irrational. Clear? So what we need to remember is, always there would be at least one question in your end exam where they will ask you to comment on the nature of roots. So first, straight away what we can say, whether the roots are equal or unequal. If D is equal to 0, roots are equal. In all other cases, roots are unequal. So D can be greater than 0 or D can be less than 0. If D is less than 0, then the roots are unequal and imaginary, because under square root of a negative quantity leads to imaginary things. So you should remember it. If when D is less than 0, the roots are imaginary. When D is greater than 0, when D is positive, then there are two situations arise. When D is a perfect square and B is not a perfect square. So when D is not a perfect square, the roots are irrational. When D is a perfect square, then look at the coefficients A, B, C. If they are rational, roots are rational. If B is irrational, then the roots are irrational. So this is important. Looking at D, you should be able to comment on the nature of roots. There will definitely be a question asking you to comment on the nature of roots in the end exam. So you need to remember this. Then the final point is, sometimes the quadratic equation is expressed in the form given here. Ax plus b under root is equal to cx plus d. So here ax plus b, when it is greater than or equal to 0, the same logic what I told, square root of a negative quantity will lead to problems. So here when ax plus b is greater than or equal to 0, only then we find solutions for this form of quadratic equations. If it is less than 0, that is ax plus b is a negative quantity, then we call the roots as extraneous. That means they have some extra quality in them, so it is complex, so we don't find the roots. Okay, so likewise, even if cx plus d is greater than or equal to 0, only then we will find out the roots of such a quadratic equation. So whenever you have a quadratic equation of this form, if they ask you to comment whether the roots are extraneous, then you look at ax plus b. If it is greater than or equal to 0, then look at cx plus d. If it is greater than or equal to 0, then the roots could be rational or irrational. But if these two quantities are less than 0, then you can say the roots are extraneous. The same way, another form of equation is ax square plus bx plus c. So dx plus c. Here also you see the under root, the under root, the under root quantity should be greater than 0 or equal to 0. It cannot be a negative quantity. So here also, before solving the equation, quadratic equation, we check whether ax square plus bx plus c is greater than or equal to 0. If it is greater, then only we go and find out the roots. If ax square plus bx plus c is less than 0, that is negative quantity, then the roots are extraneous. Clear? Thank you.